Hi everyone. Today we're going to be talking about how to calculate the slope of a line when you're given a graph of that line or 2 points on that line. So firstly, we want to clarify that slope is the constant rate of change between points on a line. How does one point change to get to the other point? It's also a ratio or a fraction of the vertical change or how it changes as we move up and down the line. We call this the rise to the horizontal change. How we move from left to right on the line. We call this the run. Overall, the slope is going to be represented by the variable m. Okay? So we have 4 types of slope here. In general, the first type that we will see is a positive slope. A positive slope has a line that goes up as we move from left to right. So it may be a little flatter like this first example. It may be really steep like the second example, but overall, as we move across the line from left to right, it is rising, it's getting higher. So this is called a positive slope. Okay, and when you have a number of the slope, when we actually calculate the numerical value of the slope, your slope is going to be a positive number. Conversely, we also have negative slopes, okay, where as I move on the line from left to right, that line is going down. Again, it might be really steep, or it might be a little more flat, but it's falling or going down as we move from left to right. That one is called a negative slope. And when we calculate the value or the numeric value of that slope, our slope is going to be a negative number. Now, we also have 2 other special cases when we have horizontal lines or vertical lines. So when I have a horizontal line, it goes only side to side and it never gets higher or lower. It's just a side to side line. For horizontal lines, the slope is 0. Okay, and when we calculate that, we're actually going to get that m, my slope, equals 0, the value. Okay, so for a horizontal line, it stays flat the whole time. Our slope is going to be 0. And then lastly, we have what's called an undefined slope. Okay, when we have a line that goes straight up and down, this has a slope that's what we call undefined. Okay, and when we calculate this mathematically, we're going to find that the value of the slope, the numerical value, is actually undefined. Okay. We're going to get into special cases a little bit more closer to the end of this video, but I wanted you to know the 4 general types of slope. All right, so while we are able to say that this example is a negative slope because we are watching it go down as we move from left to right, I know that this is going to be a negative number, but I need to be able to actually figure out what that number is. Okay, same thing with this one. I know that this is going to be a positive slope because it goes up as I move from left to right, but I don't know what that number of the slope is. So that's what we're going to find out today. So to find a slope from a graph, the first thing I want to do is find 2 points on the line. They can be any 2 points that fall on the line, but they must be on a corner of the graph. And what I mean by that is this. So for our first example, they gave us a point here and a point there. Okay, they already gave us 2 points. But if they didn't give us points, we could pick points for ourselves. I want to pick a point that's something like this one, where it crosses directly over the corner of the grid. Okay, I don't want to pick a point that's like this one where it crosses that line kind of in the middle of the box. Okay, but you can pick any points as long as those points fall on a corner of the grid line. Once I've gotten my points, I'm going to find the rise or the vertical change between those 2 points. So the vertical change, which we call the rise, all I'm going to do is I'm going to start at one point. I like to start at the point that's on the left. And I'm going to figure out if I need to go up from this point or down from this point to get to my second point. Okay, so in this case, I know I need to go down, and I'm going to go down 1, 2, 3. Now I'm in line with the other point. Okay, when we're talking about slope, we're going to use positives and negatives to show motion and direction. So if I am going to go up, I want to use a positive number to show upward movement. In my first example, I didn't go up, I went down. So I'm going to use a negative number to show that downward movement. Because I went down 3, my rise is going to be negative 3. Then I'm going to find the horizontal change, which we call the run. The run is how I move left or right to get to my next point. So I'm starting from right here where I finished finding my rise, and I'm going to go to the right or to the left. In this case, I'm trying to get to this point right here. So I'm going to go to the right, 1, 2, 3, 4, 5, 6, 7, 8, 9 spaces. Okay. Just like before, I'm going to use positives and negatives to show direction. So I'm going to use positive numbers for right movements, movements that go towards the right, that's this way. And I'm going to use negative numbers for leftward movements, left, which are going to go that way. Okay. So in my example, because I went to the right, that 9 is going to be positive. Okay. And then my very last step is to write it as a fraction with your rise number on the top and your run number on the bottom. Okay. Once I've written that fraction, I'm going to simplify. Okay. So in my example, I want rise over run. My rise was my up and down change. So my rise here is negative 3. My run is my side to side change. So in this case, my run was 9. That's going to go on the bottom. And then I need to simplify this. Negative 3 over 9, I need to simplify. Fortunately, I can do that in Desmos. So if I put in Desmos, I'm just going to put in my exact fraction here. Negative 3 divided by 9, or negative 3 over 9, if you want to do the fraction first, and then negative 3 on the top and 9 on the bottom. It's going to initially give you a decimal, but if you press this button right here, it will turn it into a fraction for you. Okay, and that will do the reduction that we need. So when we reduce this down, we get that the slope of this line, or m, equals negative 1/3. Okay, slopes are frequently fractions. Sometimes they're whole numbers, but getting a fraction in this case is not a problem. Okay, let's together take a look at our second try this one example. Remember that first I want to find the rise. The rise is my movement up and down. So it's going to be up or down. If I go up, I'm going to use a positive number. If I go down, I'm going to use a negative number. So this one already has 2 points. It's got this one right here and this one right there. So I'm just going to use those. I'm going to start at the point on the left, and I'm going to go 1, 2, up. Okay, that puts me in line with my second point. So for this example, my rise is 2. Then I want to find the run, which is my movement from side to side. Remember that if I go to the right, I'm going to use a positive number. If I go to the left, I'm going to use a negative number. So starting here, I'm going to go to the right, 1, 2 spaces. So my run is going to be positive 2. Okay. To wrap that up, I'm going to write it as a fraction of rise over run. My rise was 2. My run was 2. So my fraction is 2 over 2. And then the last thing I want to do there is simplify. Again, I can do that right in Desmos. If you press the division sign first, it will open up that fraction. So I can do 2 on the top. Oh, come on. I can do 2 on the top and 2 on the bottom, and that's going to reduce to 1. So in my second example, m, the slope, equals 1. Okay. Go ahead and try numbers 1, 2, and 3 on your own. Do the work on your paper, pause the video, work these out, then come back and check your answers against my answers. All right, for number 1, we already know that this is going to be a positive number because when I look at my graph, as I move from left to right on the line, it's going up from left to right. So I'm going to get a positive number for this. My rise, I went up 4, so it's positive 4. My run was 1, I went over to the right 1. 4 over 1 reduces to positive 4. Okay. For my second one, as I move from left to right on this line, it's going to go down. Okay, it's falling as I go from left to right. So I know that I'm going to end up with a negative number as my slope. Okay. I do my rise, which is 2 down. So I want to make sure that that's a negative 2. And then I'm going to go 4 to the right. So negative 2 over 4 reduces to negative 1/2. Okay. And then our last practice problem, again, I'm looking for a positive number because my line is going up as I move from left to right. My rise was 2 because I went 2 up. My run was 2 because I went 2 to the right. 2 over 2 reduces to 1, which is a positive number, so that makes sense with our graph. Okay. If you have questions about this, make sure you write them down. We are going to do additional practice in class, but I want to show you the other way that we're going to solve for slope here in class. So sometimes you'll be given a graph like we were just given in the last couple of examples, but sometimes they're going to give you the coordinates of the 2 points that are on the line. Okay, so for example, in my first number 1, this point here is located at 0, -2, and this point is located at 2, 1. Okay, so in some examples, instead of giving you the graph of the line, they're going to give you 2 points that fall on that line. They'll give you those coordinates. Okay, and what we're going to do is we're going to use the slope formula to solve and find the slope. So to find the slope between 2 points, we are going to label those points x1, which is the x value from the first point, y1, the y value from the first point, x2, which is the x value from the second point, and y2, the y value from the second point. Okay. From there, we're going to plug those values into this formula here. Oops. Okay. So my first step is going to be to identify which values are my x1, my y1, my x2, and my y2. So if I'm looking at this example, the x value from my first point is -2. That's going to be my x1. I'll write it above. The y value from my first point is 4. That's going to be y2, or excuse me, y1. The x value from my second point is 10. That's x2. And the y value from my second point is negative 2. That's y2. Okay, so once I've labeled those, I'm going to go ahead and plug those numbers into the slope formula. Okay. When I plug those numbers in, I need to make sure I'm using parentheses. And I need to be sure that I'm being careful with my signs. Meaning being careful whether I have a positive number or a negative number and making sure to include that in my formula. So I'm going to plug this in. M equals, in the top of my fraction, I have y1 minus y2. Okay, so I'm going to use parentheses to plug that in. y1 is 4 minus y2 is negative 2. I'm using parentheses for each of those. Okay, my subtraction sign in the middle stays a subtraction sign. Then on the bottom, I've got x1 minus x2. Okay, in this example problem, x1 is negative 2 minus x2 is 10. Okay. Fortunately for us, this is all the work that we have to do. Because once I've set this up, I can plug the entire thing into Desmos, because my very last step is to evaluate, meaning figure out what is 4 minus negative 2. What is negative 2 minus 10? And then I'm going to simplify that fraction. Okay? Like I just said, Desmos can do both of these at the same time. Okay? So when I have my fraction, I'm going to pull up Desmos. I'm going to press that division symbol so that it opens the fraction to begin with. And then I'm going to type exactly what I see here. Parentheses 4, close it, minus parentheses negative 2, close it. And on the bottom, parentheses negative 2, close it, minus parentheses 10. Okay. Again, this is going to reduce to a decimal. But if I press this button right there, it will turn it into a fraction, and I will get that my slope is negative 1/2 for this example. Okay. Try the second one with me. Again, I'm going to start with labeling my points. So 10 is going to be x1. It's the x from my first point. 0 is going to be y1, the y from my first point. Negative 2 is x2, the x from my second point. And 4 is y2, the y from my second point. Okay. Again, I'm going to set up my equation. M equals y1 is on the top, so I'm going to use y1, which is 0, minus, why are we red now? y2 is 4. Okay. Again, I plug that in with parentheses. On the bottom, I have x1 minus x2. x1 here is 10. I plug that in with parentheses. Minus x2 is negative 2. Again, plug that in with parentheses. Okay. Once I've done this part, all I have to do is type it in Desmos. I open my fraction by pressing the division sign first. Then I'm going to do parentheses 0 minus parentheses 4. Then on the bottom, 10 in parentheses minus -2, also in parentheses. Again, it gives us a decimal, but that's not a problem because I just press that button and it turns it into a fraction. In this case, my slope is -1/3. Okay. I want you to go ahead and try numbers 1, 2, and 3 here. Okay. Plug those into the formula. Go ahead and copy this down. Pause the video, work through these and see if you can find the slope. Then I want you to come back here and check your answers against my answers. All right, take just a moment to check your answers against my answers. Make sure that the numbers that you're plugging into your formula are correct. So remember, it should be y1 minus y2 on the top, x1 minus x2 on the bottom. And when you label your points, it should be x1, y1 on your first point and x2, y2 on your second point. Okay. If you have questions with this, make sure you write them down. We'll answer them during class. Okay. The very last thing we need to talk about are some special cases. So remember at the beginning, I talked about horizontal and vertical lines. Okay. So when I have a horizontal line, that line goes side to side. It does not rise or fall at all. Okay. The slope of a horizontal line is 0. Okay. We talked about that at the beginning. When I can still calculate these from the graph and from 2 points. Okay. It just looks a little bit different. So in this case, they gave me the 2 points. Again, I want to find my rise and my run. Okay. But in this case, my rise is 0. If I start from this point, I don't need to go up or down any to get to my second point. My run is going to be 1 because I move 1 to the right. When I write that ratio, I get 0 over 1. Well, 0 over 1 equals 0. So my slope is n equals 0. Okay. When I do this with my formula, if they give me 2 points, I can use the y1 minus y2 over x1 minus x2 to calculate these. 5 would be my x1, 9 would be my y1, 3 would be my x1, and 9 would be my y1, or excuse me, my x2 and my y2, respectively. So when I plug this in, y1 is 9, minus y2 is 9. x1 is 5, minus x2 is 3. 9 minus 9 is 0, over 5 minus 3 is 2. 0 over 2 reduces to 0. Okay? And when you put that in Desmos, you'll get 0 as well. Okay? I can try it again with this example. -4 is y1, -4 is y2, 9 is x1, minus 1 is x2. I can put this right in Desmos. -4 minus -4 over 9 minus 1. Oh, that should be a -4. And I'm going to get 0 for that one as well. Okay. Vertical lines are very similar, but they're just a little bit more tricky. So graphs of vertical lines go only up and down. Okay, they do not move side to side or slant at all. They're straight up and down. We talked earlier about how the slope of these lines is called undefined. Okay. The reason that these lines are called undefined is this. If I'm looking at a graph of this line, and I've got my 2 points, and I want to find my slope, so I'm going to do rise over run. My rise in this case is 1, 2, 3, no problem there. And my run is 0. I don't have to move left or right because I'm already on the point. Okay. When I set up that ratio, I get 3 over 0. Now, if you are familiar with algebra and the rules of algebra, you should know that we can never, ever, 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 ever divide by 0. It's mathematically not possible for us right now, okay? So when my 0 is on the bottom, that's a problem, okay? It cannot be calculated. It is impossible. So this is called undefined because it is unable to be calculated, okay? We will find the same thing when we try this with our points as well, okay? So if I have x1, y1, and x2, y2, I can plug that into my formula, y1 minus y2 over x1 minus x2. And when I put that into Desmos, eight minus 5 over -7 minus -7, it will say undefined. Okay, if you do this in the calculator, you may see it may say error, but in Desmos, it does actually say the word undefined. Okay, that is your answer for the slope. You can abbreviate it if you want to, but it is not the same as having a 0 slope. Okay, again, we can see with this example, I would get 6 minus 8 over 4 minus 4. Even if I don't do this with a calculator, even if I don't plug this whole thing in Desmos, 6 minus 8 is -2, 4 minus 4 is 0. When that 0 is underneath the fraction or on the bottom of the fraction, this is undefined. Okay. I know that was a lot all at once, but make sure you write down any questions you have, bring them with you to class next time, and we'll answer them then.